Hello and a warm welcome to the AI with Arun show. In this video, we are diving into one of the most fascinating technological duels of our time, the race for autonomous vehicles supremacy. Right now, the city of Austin, Texas, has become the epicenter of this competition. We are witnessing a real world showdown between two industry titans, Waymo and Tesla, each with a fundamentally different philosophy and technological approach to creating a driverless future. This video will dissect the strategies, compare the technologies, and analyze the initial deployments as they vie to define the future of transportation. Let's begin with Waymo's methodology, which is deeply rooted in the principles of redundancy and safety through comprehensive sensing. Their strategy is built on three pillars. First, it's sensor fusion. Waymo vehicles don't rely on a single data stream. They combine data from LiDAR, radar, and high resolution cameras to build a detailed, multi layered model of the environment. This creates redundancy, where the weaknesses of one sensor type are compensated for by the strengths of the others. Second is the custom AI architecture. Waymo employs a purpose built intelligence system designed specifically for safety critical decision making. This is not a general purpose AI, it is a highly specialized system. Finally, their proven track record. Before even launching in Austin, Waymo had logged over 700,000 autonomous miles, providing a massive repository of real world data to validate their systems. Tesla, on the other hand, takes a radically different and some would say a more audacious approach. Their philosophy is centered on mimicking human perception. The first element is the camera only approach. The system uses a suite of 8 cameras to capture a 360 degrees view around the vehicle. It completely omits LiDAR and radar, arguing that a sophisticated AI can derive all necessary information from the visual spectrum alone, much like a human driver. This feeds into their neural network system. Tesla uses an end to end AI that processes the raw visual data from the cameras and directly outputs driving controls, steering, acceleration, and braking. This network learns and improves by analyzing billions of miles of driving data collected from its entire customer fleet. The third pillar is cost effective scaling. By avoiding expensive LiDAR hardware and using the standard production vehicles, Tesla's approach is inherently designed for rapid and affordable deployment. Now let's break down the hardware that underpins these two philosophies. Waymo's vehicles are equipped with a formidable sensor suite. This includes 360 degrees LiDAR, which uses laser pulses to create a precise three-dimensional point cloud mapping of the surroundings. They also have multiple radar units that excel at detecting object velocity and performing in adverse weather conditions like rain and fog. This is all supplemented by a network of over 29 cameras that provide rich visual context and help identify things like traffic signals and road signs. In stark contrast, Tesla's system is built on vision. 8 exterior cameras are the primary and essentially only input. There is no LiDAR. Tesla has even gone so far as to remove ultrasonic sensors to further simplify the hardware stack. The core hypothesis here is that with a powerful enough neural network, cameras can provide sufficient data for safe autonomous driving, and the omission of expensive LiDAR hardware dramatically lowers the cost per vehicle. The difference in hardware lead to fundamentally different AI paradigms. Waymo utilizes a hybrid AI model. This system combines the power of modern deep learning for perception with a traditional rules-based software architecture for decision making. A key advantage of this is interpretability. Engineers can trace a specific decision back through the logic to understand why the car acted the way it did, which is crucial for validation and safety analysis. This approach prioritizes predictable and verifiable behavior. Tesla, on the other hand, employs a nearly pure neural network approach. It's an end to end learning system where data from the cameras goes in and driving commands come out. Instead of being explicitly programmed, the system learns driving behaviors by identifying patterns in the massive datasets from its fleet. This leads to different safety philosophies. Waymo believes in interpretability first, ensuring that every action is understood. Tesla's philosophy is that a large enough volume of real world data will allow the neural network to handle virtually any edge case it encounters, even if the internal reasoning is not as transparent. These differing philosophies are also reflected in the vehicles themselves. The Waymo fleet consists of custom modified vehicles, primarily the Jaguar, I-Pace EVs, and the Chrysler Pacifica minivans. These are not off-the-shelf cars. They undergo extensive hardware modifications and are purpose-built for autonomy, often lacking traditional driver controls like steering wheels or pedals. This results in a higher per unit cost and a vehicle that is visibly distinct from a standard car. The Tesla fleet, in contrast, is composed of the standard Model Y SUVs straight from the factory. They are regular consumer vehicles equipped with the necessary software and computing hardware for autonomous capability. This strategy has two major advantages. The hardware changes are minimal, and it makes scaling the robotaxi fleet as simple as producing more cars, leading to a significantly lower per unit cost and a much faster path to mass deployment. Now, looking at the Austin operations, the rollout strategies have been quite different. Waymo launched in March with a service area covering central Austin, and it was made available to the general public from day one. Critically, their service is completely driverless. There is no human in the driver's seat. Tesla's launch in June was more cautious. Their service is currently invite only and is geographically focused on South Austin. A key operational distinction is that every Tesla robotaxi ride includes an in car safety monitor. While this monitor remains silent unless there is an emergency, their presence indicates the Tesla system is still in the phase of supervised operation, whereas Waymo is confident enough to operate without a human backup in the vehicle. From the user's perspective, both services are managed through polished mobile apps. The Waymo One app offers 24 by 7 service with dynamic pricing, with averages rides costing between $12 and $18, and wait times are impressively low at under 8 minutes within the service area. The Tesla Robotaxi experience is integrated into the main Tesla app. For their initial launch, they're using a promotional fixed price of just $4.20 per ride and operate on a limited schedule from 6 a.m. to midnight. The early performance metrics reveal Waymo's current technological maturity. Waymo boasts a trip completion rate of 99.8% without any human intervention and an average user rating of 4.8 out of 5 stars. Tesla's completion rate, defined as trips without safety monitor intervention, stands at 92.1% with a user rating of 4.2. This data suggests Waymo systems is currently more reliable, particularly in varied weather conditions, while Tesla is still actively refining its systems with the help of its human monitors. So, what can we conclude from the showdown in Austin? In the current phase, Waymo clearly leads in terms of technological maturity and operational reliability. However, Tesla's approach, with its lower hardware costs and use of standard production vehicles, presents a massive potential for rapid, scalable deployment that cannot be ignored. Austin is serving as the perfect crucible to test these two competing visions. Looking ahead to 2026, we expect Waymo to focus on expanding its service areas to more neighborhoods, while Tesla's primary goal will be to achieve performance that allows them to remove the in car safety monitors. Both companies will undoubtedly be increasing their fleet sizes to meet the growing demand. It's far too early to declare a winner. We may find that these divergent paths ultimately serve different market segments. What is certain is that the result, data, and lessons learned in Austin will be instrumental in shaping the global rollout of autonomous vehicles for years to come. That brings us to the end of the show. Thank you for watching the AI with Arun show. Like, share, subscribe, and let us know what you think. And hope you are able to take a ride either in a Tesla Robotaxi or a Waymo anytime soon. Thank you.